Welcome to an example of classifications of functions such as one-one function, onto function, bijections, and invertible functions. Show that the modulus function f defined from set of real numbers to set of real numbers given by f of x equal to mod x is neither one-one nor onto. This time, we are given the domain and codomain both real numbers, set of real numbers to set of real numbers. And the rule fx is given as the modulus function, which means image of 3 is f of 3, that is modulus of 3, it is equal to 3. Image of 3 is 3. Image of 5 is 5. Image of 0 is modulus of 0, which is also 0. Image of minus 2 is f of minus 2, modulus of minus 2, that will be plus 2. Modulus of minus 4 is plus 4, etc. Now we need to check whether it is a one-one function. Let's go by the definition of one-one function. A function f defined from set A to set B is called one-one function or injective function if distinct elements have distinct images. That is interpreted as if you take two elements x1 and x2 in the domain, unequal elements, that should imply that their respective images should also be unequal. Or in case the images happen to be equal for some x1 and x2, if the images happen to be equal, then those elements should also be equal. These are the two interpretations of this definition. Now, in order to check this example, let me go by the first interpretation. I'm taking two numbers, x1 and x2, which are unequal. Say 2 and minus 2 are unequal, obviously. I'm taking them as x1 and x2 from the domain. 2 and minus 2, they are unequal. Now, what is the modulus of 2? Modulus of 2 is 2. Modulus of minus 2 also 2. So we can say, though 2 and minus 2 are unequal, modulus of minus 2 and 2 are equal, which means the images of minus 2 and 2 are equal. So when we took two elements unequal, it could not imply that the images are also unequal. We are getting the images equal. This example is going against this definition. This numerical example counters the definition of one-oneness. Hence, we see that distinct elements happen to have equal images. Distinct elements happen to have equal images. So it goes against the definition. So we conclude the function is not a one-one function. Now let's see whether it is an onto function. What is onto function? A function f defined from set A to set B is called onto function or surjective function if for each element taken in set B, the codomain, there should exist an x in the domain, there should exist at least one x in domain such that the image of that x is the y itself, the y that we have taken. Let's go by a numerical example here also. I'm taking y from the codomain as minus 4. Let y is equal to minus 4 taken from the codomain. Now we need to check, is there an x available in the domain whose image is this minus 4? Is it possible? For which real number can we have the modulus minus 4? Modulus of no real number can be minus 4. So we write it. There is no x in the domain. There is no x in the domain for which the modulus of x could be this minus 4. It's not possible. So second stage of this definition is not fulfilled. Hence, this y is equal to minus 4 goes as a counter example. An example that goes against the definition. An example that counters the definition. So we say the function is not onto function. Hence, this modulus function is neither one-one nor onto.